A decade ago, apps felt simpler, cleaner, more reliable. They loaded faster, broke less often, did fewer things, but did them consistently. Today, despite massive advances in computing power, cloud infrastructure, and AI-assisted development, a strange feeling has emerged. Modern software feels more fragile than ever. Apps crash, updates break features, interfaces change overnight, systems slow down under load in ways that feel unpredictable. And users are starting to ask a quiet question. How did everything get worse while technology got better? The answer is not simple, but it reveals something uncomfortable about how modern software is built. The myth of better technology equals better software. It's easy to assume progress is linear. Better tools leads to better software, leads to better experience. But software doesn't evolve like that. It evolves under constraints, speed of development, cost pressures, competitive markets, user expectations, infrastructure complexity. Over the last decade, one factor has dominated all others: speed of shipping. And speed has consequences, because when you optimize for rapid delivery, stability becomes a secondary concern, not intentionally, but structurally. The explosion of software complexity. 10 years ago, most applications were simpler. Fewer services, monolithic architectures, limited integrations, fewer dependencies. Today, even a simple app might include microservices, third-party AP, is cloud infrastructure layers, analytics trackers, authentication providers, payment systems, AI modules, real-time sync engines. The dependency problem. Nobody sees. One of the biggest hidden shifts in modern software is dependency explosion. Most apps today rely heavily on open source libraries, third-party services. External AP is cloud platforms. This accelerates development dramatically, but it introduces a new kind of fragility. You no longer control most of your system. A single update in a dependency can break core functionality. The update. Everything culture. Modern software is never finished. It is continuously updated. Weekly patches, UI redesigns, backend refactors, security updates, feature rollouts. This creates a paradox. Updates are meant to improve software, but they also introduce instability. The hidden cost of move fast. The modern tech philosophy of move fast and break things shaped an entire generation of software systems. It worked brilliantly for scaling companies quickly, but it also created long-term consequences. Accumulated technical debt, rushed architecture decisions, incomplete refactors, fragile integrations, inconsistent system design. The UI illusion problem. One reason modern software feels worse is that it looks better. Interfaces today are smoother, more animated, more visually polished, more interactive, but UI quality often hides back-end instability. A beautiful interface can mask slow database queries, overloaded servers, inefficient architecture, inconsistent state handling. Cloud scaling, the double-edged sword. Cloud computing was supposed to solve reliability problems, and it did, at first. It enabled global scale redundancy, distributed systems, rapid deployment. But it also introduced complexity, distributed failure modes, network latency issues, service orchestration problems, cross-region synchronization challenges, the rise of real-time systems and real-time bugs. Modern software increasingly operates in real time. Messaging apps, financial platforms, multiplayer systems, collaborative tools, streaming services. Real-time systems require constant synchronization across users, devices, and servers. The AI development paradox. AI has made software development faster than ever. But speed introduces a hidden problem: less deep understanding of code bases. Developers now generate code faster, rely on AI suggestions, work across larger systems, manage more abstraction layers, but they may not fully understand every component they ship. The hidden pressure of user expectations. Another major shift is user behavior. Modern users expect instant load times, zero downtime, seamless updates, cross-device synchronization, constant feature improvements. But these expectations conflict with reality. The always-on problem. Older software could afford downtime. Modern software cannot. Everything is expected to be 24/7 available, globally accessible, instantly responsive. The silent technical debt explosion. Technical debt is one of the least visible causes of software fragility. It builds when teams ship quick fixes. Instead of proper solutions, delay refactoring, patch systems under pressure, prioritize features over architecture. Why older software feels better. Older software wasn't necessarily more advanced, but it was simpler, more isolated, less interconnected, slower to change. That created the illusion of reliability. Fewer moving parts meant fewer failure points. The real reason: everything feels broken. Modern software isn't worse in capability. It is worse in predictability. Users are not reacting to absolute failure. They are reacting to inconsistency. Something works one day and breaks the next. Interfaces change without warning. The reliability crisis. Nobody measures. One of the most overlooked problems in modern software is that reliability has become difficult to measure. Companies track hundreds of metrics: user growth, engagement, retention, conversion rates, revenue per user, feature adoption, but stability often receives less attention because it is harder to quantify. When a feature launches successfully, everyone notices. When a system quietly works as expected, nobody does. As a result, organizations naturally reward innovation more than reliability. The problem is that users experience software differently. They don't care how many features were released this quarter. They care whether the application works when they need it. A messaging app that adds 10 new features but occasionally fails to send messages feels worse than a simpler app that works every time. Yet some of the most valuable engineering work is exactly that: reducing complexity, improving observability, removing unnecessary dependencies, simplifying architecture, paying down technical debt. None of these efforts generate flashy announcements. Most users never notice them, but they are often the difference between software that survives for decades and software that slowly collapses under its own weight. History shows that the most enduring systems are rarely the most complicated. They are the systems that remain understandable. Because the ultimate challenge of software engineering is not building something that works today. It is building something that can continue working tomorrow, next year, and 10 years from now, even as everything around it changes. And that challenge becomes exponentially harder as complexity grows. Final thoughts. Modern software feels more broken, not because engineers are worse, but because the system they operate in is fundamentally more complex. We have faster development cycles, more dependencies, more distributed systems, more real-time requirements, higher user expectations, constant AI-assisted generation. Each of these improves capability, but together they reduce stability. The result is a paradox. Software is more powerful than ever, but also more fragile than it appears. And unless engineering culture shifts back toward long-term system thinking, the gap between capability and reliability may continue to grow. If you enjoyed this video, make sure to like, subscribe, and comment below. Do you think software is actually getting worse, or just more complex than we can easily perceive? Let's talk in the comments.
The system isn't as simple as it seems, and this is only one piece of the puzzle. Let's uncover the next one.